Lesson 14.6, Sum and Difference Formulas. Today we will be learning a few new formulas, and really we will see many different angles either expressed in degrees or radians. These angles are non-typical angles, and we will want to express these as either the sum or difference of two known angles or standard angles on the unit circle, and then finally try an application problem to apply our knowledge. This lesson will require you to understand the unit circle. We will be using lots of these values, and when I said earlier expressing non-standard angles in terms of standard angles, these are the angles to which we're referring. These are the formulas that we will be using today. Let's not spend too much time going through those and turn to one of our first examples. Let's go ahead and try to find the exact value of the sine of 105 degrees. The sine of 105 degrees, well, now what we need to do is we need to find two angles that either sum to 105 degrees or whose difference is 105 degrees. I'm noticing right away that the sum of those two angle measures would be 105, right? So this is essentially how we will start the problem. If we go now to our formulas, you can see that we're expressing this angle measure, the 105 degrees, as the sum of two values. We will be using this first formula here. So there is the formula we just wrote down, and as we agreed earlier, 105 degrees is 60 plus 45. And now A is 60, so we have the sine of 60, B is 45, thus the cosine of 45. And why don't we in fact write that down? A here is 60 and B is 45. Now it's just a matter of going back up to the unit circle and identifying the sine and cosine of those respected angles and substituting, simplifying, and you're done. Now that we've written the formula, now would be a good time to pause the video and recall those sine and cosine values, substitute, simplify. After you've obtained an answer, press play again to check your answer. We have just made those substitutions of those values. You should end up with root 6 plus root 2 all over 2. Let's now turn to another example. Let's take a look at number 3, the tangent of 5 pi over 12, finding its exact value. First of all, 5 pi over 12 is not a standard angle. Let's go ahead and get an idea for how large of an angle that is in degrees. We will multiply 5 pi over 12 by 180 over pi. Pi will cancel. We'll get 900 in the numerator divided by 12. 75 degrees. Now what we want to do, again, like we did in the last problem, is turn to the unit circle and try to find two standard angles whose sum or difference is 75 degrees. Let's turn there. Now would be a good time to quickly pause the video and try to identify two angles whose sum or difference is 75 degrees. I'm thinking we can use those two angles there, 45 and 30. The sum of those two angles is 75. So we now go to the formulas, and we have the tangent of a sum. We will be using that formula there. So there we have it. We have written our formula down for number 3, and we have the tangent of 75, which we will express as the tangent of 45 plus 30. Now would be a good time to pause the video, write the formula in terms of those values of a and b here. A will be 45 and b is 30. So make those substitutions, and even if you're ready, go ahead and substitute the tangent of that angle into the formula. Don't forget that the tangent is the sine over the cosine. Alright, first let's point out that the tangent of 45, we need to find out its value. Tangent is the sine over the cosine, and both of those are the same for 45 degrees. We will get a value of 1. For the tangent of 30, that would be the sine over the cosine, and once you rationalize it, root 3 over 3. Let's go ahead now and substitute those values. Now you can see the substituted values into the formula, and in this line here we have simplified the numerator and the denominator. In this line here, what we have done is we have flipped the denominator, since dividing by that quantity here is the same as multiplying by its reciprocal. The 3's cancel, and we're left with this. In the denominator we have 3 minus root 3, which we must rationalize, and therefore we need to multiply by the conjugate of that, which will be 3 plus root 3. So we will multiply by this fraction here, which is really equivalent to multiplying by 1. After doing so, we will end up with this, and simplifying to that. In the numerator, then, we can factor out a GCF of 6, and those 6's will cancel, leaving us with 2 plus root 3. So the exact value of the tangent of 75 would be 2 plus root 3. Next, let's take a look at number 5. This one appears to be a little bit different. You can read the problem. We are given the sine of a. Now, if we use this formula that we're given a few pages earlier in the presentation, the sine of the quantity a minus b will be the sine of a cosine b minus the cosine a sine of b. Now, what's interesting here is that we're given the sine of a, which is 8 over 17, and we must also then find the cosine of a. They tell us that a is in quadrant 1, so I'm going to pause the video and sketch out a triangle with those side lengths. Next, so you see the triangle that we have sketched out in quadrant 1. There's our reference angle A, and the sine is the opposite side over the hypotenuse. We can next use the Pythagorean theorem to find our missing side, and then we will be able to have the cosine of A in our formula. So now the adjacent side to angle A is 15. We are given the sine of A. Now we know the cosine of A. We know that expression in the formula, and we also know this. Now we need to talk about angle B between pi and 3 pi over 2. That will be in quadrant 3, and we are given the cosine of B to be negative 24 over 25. Let's do the same thing we did before and sketch out that triangle in quadrant 3. I will pause the video. Go ahead and make a sketch of what you think it would look like, and then after you're done, use the Pythagorean theorem, find the missing side, and press play to check your answer. there is the triangle that you should have. Also, take notice that both the sine and cosine are negative in quadrant 3. We are given the cosine of b, and using the Pythagorean theorem, we find that leg of the triangle to be length 7, but again, the sine is negative in quadrant 3, so we will make it negative. So now looking at our formula, earlier we agreed we had the sine of a and the cosine of a. Now we have the cosine of b and the sine of b. So we will simply substitute those values into the formula and simplify. Let's do that now. You may pause the video, substitute, simplify, and let's see what answer we both get. Here in this line, you can see the substitution of those values we found. And proceeding to the next line, we have simplified it. Your final answer then, negative 87 over 425. Let's now take a look at number 7, the cosine of x minus 2 pi. We will use the cosine difference formula, so we will have that substitution initially, given those values of a and b, namely a is x and b here is 2 pi. After that, we can simply use our unit circle and substitute the appropriate values for the cosine of 2 pi and the sine of 2 pi. You may now pause the video, substitute those, and then simplify it a bit. You should have that for your substitution, and so we will be left with this. Our answer is the cosine of x. Okay, please never mind this work here. Turns out I had to go and I ran out of time trying to fit all of this problem in less than 3 minutes, and it didn't work out. Anyhow, I'm going to... Okay, we're now going to work through problem number 9. This is a long problem. There will be many pause points since there are only about 2 minutes left in the video. Notice first of all that we needed to express pi t over 75 as either a sum or difference, and we did it with that expression. We also canceled a 5 from each side. Let's now use the cosine and sine sum formulas. You may pause, work it out, and then play when you're finished. You should have in line 2 that equation. Notice also below that in line 3 we substituted that. The sine of 0 is 0. That entire term will become 0. In radian mode we evaluated the cosine and sine of 22, getting these values. We next need to distribute the negative 24. Pause, simplify it, and then press play. You should now have, after distributing that line here with that equation. Now what we want to do, we want to bring the cosine to the left side, combine terms, and then let's see what we have now brought the cosine terms to the left, simplifying to this. Now notice that if we divide both sides by the cosine of pi t over 75, we will have the tangent. And then, of course, we'll also divide by 24 to get that on the left side. What you can do now, if this expression, pi t over 75, is throwing you off, let it be some simple variable. Call it x. Then we would have this equation, and then you can understand that easily. So you would take the tangent inverse of that ratio to get this. But then x is pi t over 75, so substitute it back in, right? That is x, substitute it here, and solve for t. You will get that t is 5.65. Please also complete the reflection.